Good afternoon. Please switch off your video. Who is this? Switch off your video. Sushil Kumawat. Switch off your video. Switch off your video. Switch off your video. Sushil Kumawat. I'll start. Uh, Yesterday there was some internet issue. I could not able to complete the problem. And we need to find the shear force. I have left at this point. I have left at this point. Uh, Last section BC. You have written the equation. Can you tell me what is f at x is equal to 10 and f at x is equal to 12? Can you tell me this value? 10.6 minus 17 plus 24, so 12.4. How much? How much? How much? 10.6 minus 17 plus 24, 12.4. How much, Raghavendra? How much? Is it audible?
Yes, sir. Audible. 1 minute, sir.
Please tell me. Dhruti, how much? Mekala? Harish Paul, Rakesh, Sushil Kumawat,
Sir, 6,
and then the text is equal to 12?
0.
0. So you have to get back
0.
0. Okay, let me write the bending moment equation. M at x is equal to 10. M at x is equal to 10. It should be equal to 10.6 into 10 minus 8 into 8. 10 minus 2, 8 minus 6 into 6 minus 3 into 4. This is 0. That is 0. tell me both this now. M at x is equal to 12, which is equal to 10.6 into 12 minus 8 into 10 minus 6 into 8 minus 3 into 6 plus 12.4 into 2 minus 3 into x minus 12 minus 2, 10 is equal to 2, 2 into 2, it's 4 by 2. Tell me both the values. One not 6 minus 60, 1 not 10.6 into 6, 1 not 6 minus 64 minus 36 minus 12. Minus 6, minus 6, this has to be 0. You check it out, it has to be 0. Minus 6 kilonewton meter, this is 0. 6 kilonewton. Are you getting 0?
Yes, sir.
Okay.
Yes.
Now, f at x is equal to 10 is equal to 6 and f at x is equal to 12 is equal to 0. F at x is equal to 10 is equal to 6. This is how much? 6.4. 6 will be 6.4. This is negative 6.4. 6 will be positive 6 will be like this, and then it becomes 0. This is constant. This should be linear. You should not draw a line like this and join. This is linear like this. Okay. Bending moment, shear force is like this. We'll go back to that and we'll look at linear. It should be quadratic. This is like this, right? Like this. It was like this. It was like this. Therefore, please whoever don't talk. Not supposed to talk in between the class. This is like this. Therefore, slope will be like this. This is the slope. Let me draw the curve. This is how the slope will be from minus 6 to 0. This is what this completes your problem. I completed almost all varieties of problem. Next I am left with I will starting the bending fourth module from next week. Tomorrow also I will solve some few typical problems so that you will get confidence. I will solve one more problem for curiosity. Cantilever in the sense you should have a reaction force and a counterclockwise momentum. Okay, whereas in case of simply supported beam, there is no moment. It will not withstand the moment. It will simply fall off. Cantilever, there is a reaction force Ra and moment Ma. Okay. Now, there is a moment 5 kilonewton meter, and there is a point load 10 kilonewton. There is a moment 10 kilonewton. Kumawat, Sushil, could you please switch off your video? 10 kilonewton. And at the tip, there is 5 kilonewton. Sushil Kumawat, switch off your video. Sushil Kumawat, switch off your video. Okay. Replicate this. Five kilonewton, 5 kilonewton meter, 10 kilonewton, 10 kilonewton meter, 10 kilonewton meter, 5 kilonewton. Find reaction. Summation of vertical forces should be equal to 0. Summation of force and moment should be equal to 0. There is no longitudinal forces or forces in x direction. Therefore, only y direction force should be equal to 0. Ra minus 10 minus 5. Ra minus 10 minus 5 is equal to 0. Ra is equal to 15 kilonewton. Okay. Ma also we should find. Ma, due to the boundary condition, there is a support, there is a moment in a counterclockwise direction. Summation of moment m summation of moment about A should be equal to 0, which is equal to, I will consider clockwise moment as positive, which is equal to minus Ma minus Ma minus Ma minus E plus 10 minus, this will be clockwise 10 into 440, 5 into 2468, 2465 into 40, minus Ma plus 5 plus 80, Ma is equal to 85 kilonewton meter, or it is nothing but minus Ma is equal to minus 85, or Ma is equal to 85 kilonewton meter, right? That is, whatever direction which you assume is uh, is comfortable or is in the same direction. My assumed direction and obtained value is same. Okay, therefore Ma is 85 in this direction, Ra is 15 kilometer. Assumed direction and what we have obtained is the same. Okay, these are vectors. Right, segment segment. I'll pass a segment here, x1, x1, okay, segment AB, x greater than or equal to 0, less than or equal to 2, this, right, this RA 15, counterclockwise moment 85, and section XX, distance x for shear force, summation of vertical forces. This is not equal to 0, summation of vertical forces, that is from left hand side. Okay, acting upwards is positive, 15 kilonewton. Moment will not come into picture. Moment in the sense two equal and opposite forces separated to certain distance, 5 kilonewton, 5 kilonewton, which will constitute a moment. Therefore, this is 0. Total effect is 0. But it will rotate like your steering wheel. If you take your steering wheel, if you that is your steering wheel, if you, while you are steering your car, if you take the total effect, when assume that you are turning your wheel to the left hand side, left you are taking a turn towards left. When you're taking a turn towards left, will steer the wheel towards left hand side. The total effect is for the total force is 0. We are pushing your right hand towards right hand side, that side, and left hand side you are pulling it. Total force is 0, but isn't the steering wheel is rotating? The same thing implies here. Total force is 0, but it is rotating. Moment is not equal to 0. Okay. Then m is equal to summation of moment about xx is equal to, right, if this is my beam, if this is the moment, this is positive xx, if this is the moment xx, then negative. Okay, the moment this is bending the beam like this has to be positive 15x, and moment this is in the same direction as this, like this. Therefore, this is hugging minus 85. Moment about x is equal to 0 is equal to minus 85. See, when there is a moment, there is sudden jump in the bending moment diagram, either upwards or downwards. Moment at x is equal to 2 is equal to 30 minus 85, which is equal to 55 minus 55 kilonewton meter. We'll draw A, B, C, D, E. Load diagram, shear force diagram. In most of it, I have shown you how to find the maximum bending moment. I have not shown you point of controversy, right? One problem will solve how to find the point of controversy. Or one of the problem I will tell, and I will take the one of the problem and I will tell you how to find the point of controversy. Maximum bending moment in the sense where the shear force is 0, when the shear force curve crosses the beam axis, that is this line, then that is the point where shear force is 0. Equate that equation to 0 and get the value of shear force and that distance from left hand support as in is in our case. Okay. F at F is 15 kilonewton constant, there is no load. F is 15 kilonewton constant, and then at this region moment is how much? Minus 85 and minus 55. Minus 85, I'll write like this, minus 85. Okay, this is constant, this will be linear, 55 will be like this. Next. Section figure SFD and BMD. Section BC, x greater than or equal to 2, less than or equal to 4. Figure RA 25, sorry 15, 15, 15 and 85, 15 and how much you got? What is the value of this moment about x is equal to 2 minus 60 minus 30? What we got? Please check it out. What is the moment we are getting it? Minus 85, 15x minus 85. What is the value we are getting it? Okay, minus 60 minus 85. Oh, so it's right. Minus 85 minus 85. Okay, and this is 15, and then this is, and then this is 85 in this direction, and there is a moment at point B, which is 5 kilonewton meter, and this is my section, which is at a distance x. F is equal to summation of forces, okay, R, which is equal to active force is positive, plus 15 kilonewton. F is equal to M is equal to summation of moment about F, which is equal to 15 into x. It is bending the beam like this. This is negative 15x minus 85 plus 5 m at x is equal to 2, which is equal to 30 minus 90 is equal to minus 60. M at x is equal to 4 is equal to 60 minus 90 is equal to minus 30. X is equal to 2. Since there is a bending moment, there is equal to minus 60. See, there will be a sudden jump like this. From minus 55 to minus 60, there will be a jump like this, 60. And then from once again, from minus 60 to minus 30. 60, there is no load, minus 30, load, no load. Let me write the shear force first. Shear force, it's 15 kilonewton constant. 15 kilonewton, this is constant. B2C section, 15 kilonewton. Shear force constant, bending moment linear. Linear of magnitude how much? Minus 30. Minus 30. 0 constant linear. 0 constant linear. Sudden jump. Sudden jump. Okay. Really? Okay. Next. Section figure SFD and BMD. Section CD x greater than or equal to 4, less than or equal to 6. Figure 15, 85, B, C, there is 5 kilonewton moment, 10 kilonewton, section CD, x is 2 meter, 2 meter. Okay. is equal to summation of vertical forces, which is equal to 15. There is you should force in the sense take only force, not the arm length. 15 minus 10 is equal to 5 kilonewton. Okay. Moment is equal to summation of moment of x, which is equal to 15 magnitude into x, and the counter proportionality minus 85 minus 5 this is bending the beam in this direction, minus 10 into x minus 4. Okay, this 10 into x minus 4. Moment at x is equal to 4 will be 60 minus 90, which is equal to minus 30. Moment at x is equal to 6 will be 6 and 90 minus 90, which is equal to 0. Right? Anything mistake I have done? 15 6 90 minus 90, oh, this plus 90 minus 10 into minus 10 into 2 minus 20. 6 minus 4 is 2, is equal to minus 30. Okay, this point between section C and D, shear force is 5 kilonewton. 5 kilonewton. Shear force is 5 kilonewton. At this point, there is a sudden fall 5 kilonewton throughout 5 kilonewton. Okay. Kilonewton, and then this is between section C and D, minus 30 and minus 20, minus 30, this is minus 30, this is minus 30, minus 30, minus 20, this is constant, this will be linear, plus or minus 20, minus 20. Okay. Last section, left with 10 minutes, I completed. Last section, section D, section figure figure SFD BMD. Is it audible? Is it audible? Raghavendra? Dhruti, is it audible? Dhruti? Mikala, is it audible? Is it audible? Is it audible now? Ruti, is it audible? Nikala, is it audible?
Yes, sir, audible.
Okay. And the payments will take x greater than or equal to 6, less than or equal to less than or equal to 8. Figure, this is where I'm passing the section 1, 2, 3, 4 section x4, x4, a, b, c, d. This is x, this is 15, this is 85, this is 5, this is 10, this is 10. F is equal to summation of forces, which is equal to 15, 15, 15 minus 10 is equal to 5 kilonewton. M is equal to summation of moment about x, which is equal to 15 into x minus 85 minus 5. If this is the section, if this is the section, this is bended like this is positive x. This is, if this section is bent like this is negative. Smiley face is positive. Since towards the right hand side the section is here, this is also clockwise, this is also clockwise, therefore this is positive 10, positive 10. Your section is right hand side, section is right hand side, and the moment is acting at the left hand side clockwise, therefore positive 10. Therefore m at x is equal to 6, which is equal to 90 minus 90 plus 10 is equal to 10. Okay, is it plus 10? 15, 6 and 90 minus 90. Give me a moment. This is acting clockwise. This is clockwise. To from the right hand side of the section. This is smiley face. This is face. Okay. And also I left out this one. Minus. This is minus 85. This is minus 85, right? How much is this? This is minus 85. 56 and 90. If you take a minus 85 into consideration, somewhere other force on force. 56 and 90. 15x minus 35 minus 5 plus 10 plus 10 plus 10 into x minus 4. Okay, plus 10 plus 10 into this will be ix is equal to 10 into 2. This will be, sorry, how to do this will be like this. This is minus 10 into x minus 2. This is equal to minus 10. M and x is equal to 8 will be 15 8 is 120 minus 90 plus 10 plus 10 into 8 minus 4 is 4. This is equal to 30 plus 10, sorry, 30 plus 10 minus 10 is equal to 0. We'll come back to 0. Okay. Now shear force is 5 kilonewton. 5 kilonewton constant, on constant. If you take at this end, this 5 kilonewton, it should come back to 0 like this. So this is also 5 kilonewton constant. Why? Because if you take the section here, section towards right hand side, and if the force is acting, this is positive. Section, assume that the section is here, and the force is acting downwards. And this is negative shear force. This is positive shear force. Okay. And bending moment, this is minus 10 and 0. Shear force is constant. Bending moment, since there is a moment, will suddenly jump to minus 10 like this, minus 10, and it will go linearly up to 0. This is a straight line, minus 10 and to 0. You cannot draw a straight line here. You assume that this is a straight line and 0. This is 0. I completed almost all varieties of problem. Tomorrow's class, I will just engage for your any clarification or any doubts. You can ask me. I'll complete one or two problems in tomorrow's class, and then we will start the fourth module. Okay, bending, and I may require another 8 classes to complete it. Okay. Any doubts you are having? Any doubts? If there is a moment, there will be a sudden jump in bending moment diagram. If there is a point load, there will be a sudden jump in shear force diagram, as you can see at point C. And at point B, there is a sudden jump in bending moment diagram. At point C, there is a sudden jump in shear force diagram. At also point D, there is a sudden jump in shear force bending moment diagram. And so at point T, there is a jump in shear force diagram. Any doubts you are having? Any doubts? Shall I stop at this point?